Okay guys, so this is going to be our first set over integration. Um, so you have your power rule integration, you add 1 to the exponent divided by the new exponent, u sub, and then we have our trig integrals, our inverse trig integrals. Next page continues the inverse trig integrals that you need to make sure you memorize. Exponentials, and your first FTC that says that the integral of f prime of x is equal to f of b minus f of a. Okay. Second FTC, you need to make sure you know that. That's the derivative of an integral. Remember on this one, we take a derivative of an integral, we plug in the top limit, and then we chain rule the top limit. And then average value of a function is 1 over b minus a times the integral. Okay, so as we go through this, I'm going to go through these rather quickly. So first example, we're going to add 1 to the exponent, divide by the new exponent. So it becomes 4/3 x cubed plus x plus c. Next one, we're going to rewrite this as x to the 1/2 power minus 2. We're going to integrate that. So we add 1 to the exponent, divide by the new exponent, and plus c. This one we have a u sub. Your u is going to be x cubed minus 8. Your du is going to be 3x squared dx. We don't have the 3 on the outside, so we got to get rid of it. So it becomes 1/3 the integral of u squared du. Add 1 to the exponent, divide by the new exponent, so it becomes 1/3 times 1/3 u to the third plus c. So your answer is 1/9 x cubed minus 8 all to the third power plus c. Now, how do I know this is a u sub? Well, anytime you have something other than x raised to a power, or it's underneath the square root, that's going to be your u. Next example problem. We're going to divide this up. Okay, so when you have one thing on the bottom, you can split it up by division. So this is going to be x squared minus 5 all over x to the 1/2. And when I split this up, 2 minus 1/2 is going to be 3/2. So there's x to the 3/2 minus 5x to the negative 1/2 before we integrate. Now we'll go to integrate that. We're going to add 1 to the exponent, divide by the new exponent. Remember, when we divide by a fraction, we multiply by the reciprocal. So add 1 to this, it's going to be 1/2, and multiply by 2. Next one, your u is going to be sine of 9t. Your du is going to be 9 cosine of 9t dt. We don't have the 9, so we got to get rid of it. So this becomes 1/9 the integral of u cubed du, because my u is being raised to the third power. And we're going to add 1 to the exponent, divide by the new exponent. So it's 1/36 sine to the 4th of 9t plus c. Next example problem. Your u is going to be on the bottom. Your u is going to be 4x squared plus 9. Your du is going to be 8x dx. Now, I don't have the 8, so I'm going to get rid of it. And I have the 2 out front over here, so I'm going to do 2 times 1/8 is 1/4. So this becomes 1/4 the integral of u to the negative 1/2, because your square root is on the bottom. So when I integrate this, I get u to the 1/2, and multiply by the reciprocal is 1/2. 2 times 1/4 gives you 1/2 plus c. And that's what we get for our answer. Okay, next one. Your u is 3x squared. So on trig, most of the time your angle is going to be your u. Your du is 6x dx. Got to get rid of the 6, so it's 1/6 du is equal to x dx. So I get 1/6 integral of sine of u. The integral of sine is a negative cosine. So it's negative 1/6 cosine of u plus c. Okay, and then we're going to substitute our u back in. Okay. This one, your u is going to be tangent because the derivative of tangent gives you a secant squared. Okay, and then you don't have to manipulate anything. This just becomes the integral of u to the 5th du because your tangent's being raised to the 5th power. Integral of that's 1/6 u to the 6 plus c, and then I'm going to substitute back in. Okay, next one. So your u in this case is going to be the sine because it's the angle. Your u is sine of t. The derivative of sine is cosine, which I have that on the outside. So this becomes the integral of cosine of u du. And the integral of cosine is sine. So this becomes sine of u plus c. And our u was sine. So this is sine of t plus c. E's. When we're dealing with e's, your u is going to be your exponent. I have the 14, so I've got to get rid of it. So this becomes 1/14 integral of e to the u du. The integral of e to the u du goes to e to the u. Okay. Next one, your u is going to be x squared plus 2x. Your du is going to be 2x plus 2. Now, I don't have the 2x plus 2, but I can factor out a 2. So I'm going to divide by 1/2. Divide by 2. So we get 1/2 the integral of e to the u du is equal to 1/2 e to the u power, which is x squared plus 2x plus c, like that. Okay, next example problem. We get into some natural logs. Okay, so your u is on the bottom. I know this is going to integrate to a natural log because it's 1 power less on top than it is on bottom. So the derivative of this is 3 dx. I don't have the 3. So it's 1/3 the integral of du over u, which goes to 1/3 natural log absolute value of 3x plus 5 plus c. Don't forget your absolute value signs. Next example. U is equal to x squared plus 1. Your du is going to be 2x dx. I don't have the 2, so I got to get rid of it. So it becomes 1/2 the integral of du over u, which goes to 1/2 natural log absolute value of x squared plus 1 plus c. Next example. Your u is 9 minus 12t. Your du is going to be negative 12 dt. I don't have the negative 12, so I have to get rid of it. And this is e to the u du, which goes to e to the u. All right, I keep hitting my stand. Okay, next one is going to deal with a to the u du, natural log of a. So your u is going to be t squared. Your du is going to be 2t. I don't have the 2, so I got to get rid of it. I also don't have the natural log in this form. So this becomes 1/2. So it becomes 1/2. And I have to divide out the natural log of 5 because I don't have it. 5 to the t squared power plus c. Okay, next one follows the inverse tangent form, du over u squared plus a squared. So we have to identify our u first. Your u is going to be the square root of this, which is 2x. Your a is going to be 3. So we're going to follow our little formulas. It's 1 over 3 inverse tangent of u over a, which is 2x over 3 plus c. Okay, we're going to do the same thing on the next one, but it's going to follow the inverse sign, okay, formula. So your u is going to be 5x, your a is going to be 2. Now, on inverse sign, it doesn't divide by the 1 over a in front. So this is inverse sine of 5x over 2 plus c. Inverse sine and inverse cosine are the only ones that don't divide by the 1 over a in front. Okay, this one right here. So your u is going to actually be inverse tangent in this case. Your u is inverse tangent. Your du, the derivative of inverse tangent, is 1 over 1 plus x squared